Hi guys, welcome back to my system design series. In this video, we are going to discuss why we need partitioning and what are secondary indexes. And we will understand the difference between primary and secondary indexes. Further, we will discuss two main types of secondary indexes. Those are document partition and term partition. We will also explore pros and cons of each type and real-world examples. Imagine trying to find a specific book in a large giant library which is not having any section, not having any compartment, or not having any shelves or catalogs. It will take you forever to find a particular one book. So, to solve that issue, modern databases uses partitioning and indexes to handle large volume of data. A primary key is a unique ID for each record, and the database automatically builds the primary index on it for fast, direct lookups. In contrast, secondary index is built on another column to speed up the searches by that column. For example, the car database uses the vehicle identification number VIN as a primary key and color as a secondary index. That means many cars can have the same color, so color index entries might be repeated. In real life, you can take an example of primary key as your passport or Aadhaar card number. Those are unique, and secondary indexes are kind of your surnames which have multiple entries in phone book, which helps to find the people by name, but many people can have the same surname. So the index entries are not unique. Partitioning is used to scale databases and handle very large data sets. Instead of one giant table, the data is split into multiple partitions. These queries runs in parallel and prevents any one server to become a bottleneck. Okay, let's discuss document partition indexes. In document partition schemes, each partition stores both the data and the secondary index for that data. For example, imagine two car showroom branches, branch 0 and branch 1, each with its own list of cars and a local index by a color. Partition 0 might list down all the red cars having the IDs of the cars from 1 to 100, and partition 1 might list down its own red car having the ID as suppose 101 or 102. If we want all the red cars in the database, then we must query both the partition and merge the results. This is called a scatter-gather query. How it works? Each branch has its own color catalog. If you are looking for a red card, then you will ask all the branch catalog and then combine the results. And how it updates or writes? When a new record is added to a new partition, only that partition index is updated. This makes writes simple and fast since updates stays local. However, for reads, document partition indexes are less efficient. A query by secondary field must be sent to all the partitions and gather the result. This scatter-gather query makes the read slower and more complex. If one partition slows to respond, whole query needs to wait. Okay. Next is term partition, global indexes. In term partition, the secondary index is a global across all the data, but it is partitioned by the index term. In our car example, all the red car entries are stored into the one partition. For example, partition 1 holds a color such as A to R, and another partition, suppose partition number 2, holds a color from S to Z. To find the red cars, you first need to find out the partition which contains only the red index and query only that one partition. So, how it works? Imagine a central catalog of all cars color split by color group. All red car references are in the red section of the catalog in one shelf. To find the red car, you just need to go into that one particular shelf which is holding all the references. Okay, let's talk about reads. In this, searching by an index value is sufficient. You contact only one partition that holds a particular red references instead of all the partitions. Let's move towards the writes. When adding or updating a record, we must update the global index entries for each index term. If a car has multiple index attributes, each one may live on different partition, so the write must update on several places. This makes write slower and more complex. Often the index updates are asynchronously, meaning the database returns success before the global index is fully updated, potentially causing primary inconsistencies. For example, DynamoDB's global secondary indexes are updated asynchronously and can be momentarily out of date. Okay, let's move forward. Let's talk about the differences between global and local indexes. In local, while doing write, it touches its own index partition, so that's why it is fast and simple. While in global, during writing, it is touching multiple partition indexes. That's why it is slow. Now let's talk about the reads. In local, queries by the index field must be broadcast to all the partition. That's why it is having more work and higher latency. While in global, during reads, queries target only one partition that is holding the term. That's why it is faster to read and it is easier to do the range queries. For example, find the colors from blue to orange if colors are lexically sorted. Now let's talk about complexity. In local, it is having the simpler design, no extra coordination for writes. But read-side logic or client must merge the results. Susceptible to tail latency, the query is as fast as its slowest partition. While in global, it is more complex, probably requiring cross-partition transactions for full consistency. Usually needs eventual consistency logic. It have better read performance in return for write complexity. Okay, next is performance trade-off. It have very fast writes, reads by non-key fields are very slow, and it scales poorly as partition increases. While in global or term partition, it have the fast reads and scalable search, but slow writes and potential temporary inconsistency. Global index is also called term indexes and local index is also called document indexes. Okay, let's move forward. Let's discuss pros and cons of both the indexes. Let's start with the local index. The pros of using this are it is simple to write and update. It maintains the strong consistency per partition. It works well if most of the queries include the partition key. Now, the cons of using this are queries by secondary index require scatter gather across all the partitions, which is expensive and slow. In this, it is hard to do global range scales or joins. Now, let's talk about the global index. The pros of using this are efficient reads by term. You only query the relevant partition, eliminating most scatter gather. It can support global searches and range queries more naturally. But the cons of using this are writes becomes complex. You may need to update multiple partitions index to update only one record, often asynchronously. This can lead to eventual consistency. Immediately after writing, the index might not reflect the change. System complexity and core logic are higher. Okay, let's move forward. Let's talk about the scatter gather queries. A scatter gather query is when the database sends the query to all the partitions and combines the result. In document partition indexes, searching a secondary field, for example, searching by color, usually requires scatter gather query. This is expensive because it involves the network calls to the all servers and an extra work to merge the results. Crucially, the query needs to wait for all the partitions to respond. Even if one machine is slow, the user have to wait for a longer time. This tail latency can significantly degrade the performance. It is like asking to every branch of a store for the available stock and waiting for the slowest branch to respond before answering to the customer. Okay, now let's talk about the consistency and latency tail issues. Okay, let's talk about consistency first. In global indexes or term-based indexes, updates to the indexes are often applied asynchronously. For example, when a DynamoDB writes secondary index, it returns success quickly, but the index may not include the new item for a short time. This means the query might temporarily miss the recent updates. The system must handle this by retrying or waiting. In document-based indexes, each partition's index is immediately updated with its data. So the consistency issue is less common, but the application must still deal with the merging results. Okay, now let's talk about the tail latency. With scatter gather, the overall time is dominated by the slowest partition. For example, if one server has a hiccup or heavy load, all the queries having secondary lookups must still wait. This can cause unpredictable delays. System typically tries to mitigate this by replicated partitions, timeouts, or repartitioning data. but it is an inherent challenge of a document partition approach. Now let's talk about the real world examples. Many NoSQLs and distributed systems uses local secondary indexes. MongoDB, Apache Cassandra, Elasticsearch, React uses this. This system favors fast writes and scattergather reads for secondary indexes. Amazon's DynamoDB's global secondary indexes are term partition. The index is partitioned by the index key and updated asynchronously. Some distributed SQLs and new SQLs also support the global indexes. The trade-off is that they get the faster reads by keys but must handle the complex index updates. So that is for this video. We have discussed partitioning, secondary indexes, difference between primary secondary indexes, document partitioning, term partitioning, pros and cons, scatter queries, and real world examples. So if you are still watching this video, then please make sure you like, comment and subscribe to my channel. It will help me and motivate me to make more videos. Thank you so much for watching.